Okay, so the question is, an experiment succeeds thrice as often as it fails, right? So this experiment, whichever they are doing, is not as fair as tossing of a coin, right? Because in tossing of a coin, both the outputs are equally favorable, right? Here what is happening, the expectation of succeeding is thrice as it is for failing, right? Then find the probability that in the next 5 trials there will be at least 3 successes. So whenever we are doing an experiment where the probability of success and probability of failure is not changing, and we are doing that particular experiment for more than one time, right, then this clearly indicates that the question belongs to the concept of binomial probability. Okay. Okay, so what happens is, let me just introduce binomial probability to you. So in binomial probability, if I am doing some event, let us call that event A, and the probability of success is, let us say, P, and probability of failure is Q. Now if I am doing this A event, let us say n times, okay, and the question is, in these n times, what is the probability that I will get success r times? If this is the question, then the value of probability comes out to be something like this: NCR into success. How many times I want success? I want R times success. So the remaining times I should get failure, right? So it will become N minus R. This is the formula of binomial probability. We will be applying this formula directly in our question, right? So first of all, we will have to find these two values: probability of success and probability of failure. Okay, so according to the statement, the success probability is thrice as that of failing, right? So if I call the success probability of as P of A and failure probability as P of A bar, then we already know that the sum should be equal to 1. But PA is already 3 times of PA bar, right? Which means my equation will become like this, which means that probability of failure, which I am calling Q, will become how much? 1 by 4. And after using this equation, we will get the value of P, which is actually probability of success, as 3 by 4. So we have these two values with us, value of Q and value of P. Now from the question itself, it is very clear that since I am doing the experiment 5 times and I want success at least 3 times, so my value of N will be equal to 5. But R will vary now. Since I want at least 3 successes, so I can take R value as 3, 4 and 5. All these 3 values are acceptable for at least 3 successes, right? So let us use this formula 3 times then, right? Either I will get success 3 times, or I will get success 4 times, or I will get success 5 times. So whenever we use the word or in our statement, we have to add those cases. This is the general idea, right? So I will be just adding the values which I obtained using these formula. Okay, so it will look like this: 5C 3 into success is 3 by 4, success to the power 3 into failure 1 by 4 to the power 1, right? Sorry, power 2. Okay, then second case is what? When I get 4 success. So for 4 success I will get, write 5C4, success how many times? 4 times, and failure only 1 time. And the third case is when I get success all the time, which means that success is there for 5 times and there is no failure, right? So you will have to just simplify these values. If you have to find 5C3, then let me just tell you what will happen here. So we are applying the standard formula. 5C3 is nothing but 5 factorial upon 2 factorial 3 factorial, which reduced down to 10. Similarly, you will find the value of 5C4, which is equal to 5, and then 5C5, which is equal to 1, right? So now you can calculate this value. This complete value will come out to be equal to 459 upon 512. This is your final answer.